When the James Webb Space Telescope launches on Boxing Day 2021, the planet will change. This advanced telescope, with its high-precision and high-resolution infrared optics, has changed our understanding of the universe since its release. Using his stunning observations of the early universe, James Webb has shed light on the evolution of stars, galaxies, and planetary systems, including our own solar system. But the capabilities of the telescope have exceeded all expectations, although it revealed many galaxies, some of which were obscure. Astronomers said they could only find a few. These early galaxies challenge our current planetary models and question accepted ideas about the origin of the universe. As we explore the distant world, our imaginations will be tested. If we go back in time, one would think that the number of large galaxies would decrease, but James Webb's findings are different. There are many random galaxies, older than the universe. By examining these ancient galaxies, we are asking the universe about its early years and how it evolved into its present state. With its exciting capabilities, the James Webb Space Telescope will push the boundaries of human knowledge and may change our understanding of the history of the universe. In addition to recording global events, the website is also rewriting our story of the universe's origins by showing galaxies that are billions of years old. Projects like Webb's Source and the Cosmic Evolution Early Release Science Survey are challenging our assumptions and expanding our understanding of the universe. The Tabletop Galaxy, named after the daughter of scientist Stephen Finkelstein, is one of these amazing discoveries. This 13-billion-year-old galaxy has amazed scientists with its brightness and color, revealing that our universe is richer and more complex than previously thought, challenging the fundamental theories of the universe. First, the James Webb Space Telescope's use of infrared wavelengths is due to its incredible ability to see distant galaxies. The use of this wavelength is necessary to study galaxies that have been significantly displaced by the expansion of the universe. Although the Hubble Space Telescope has discovered some distant galaxies, observing the light in the optical region, Hubble's instruments had difficulty seeing some of these distant galaxies. James Webb accelerated these achievements after a few days of the start of his scientific work. He discovered many galaxies far beyond what was previously thought. Scientists often estimate the age of these galaxies rather than their distance. This approach addresses the challenge posed by the expanding cosmos to conventional distance measurements. Take Maisie's galaxy, which is estimated to be 13 billion years old. Even though it took 13 billion years for the light from this galaxy to reach us, it is now much farther away than its age would imply due to the continuous expansion of the universe. By examining spectral lines, the near-infrared spectrograph on the James Webb Telescope helps determine the ages of these galaxies with greater accuracy. Photometric observations initially suggested a redshift estimate of 11.8 for Maisie's galaxy, but subsequent spectroscopic investigations revealed a redshift of 11.4, placing it among the 4 oldest galaxies verified by spectroscopy. These findings contradict past cosmological theories by suggesting that galaxy formation began sooner and progressed more rapidly than previously believed. The discovery of galaxies formed just 10 million years after the Big Bang suggests that massive galaxies are forming faster than expected, with major implications for our understanding of dark matter and historical structures of the world. While these findings do not disprove the viability of popular planetary models, they do point to the need for further research. James Webb's discoveries have changed our view of the evolution of the universe, revealing a universe much larger and more complex than previously thought. Scientists hope that further observations made with this first telescope will further our understanding of the formation and evolution of the universe. Since the galaxy's planets are mostly made up of stars, luminosity is closely related to mass. Astronomers can estimate the total mass of a galaxy by assuming a specific average brightness and mass for each star. This mass-to-light ratio provides insights into the types and distribution of stars within the galaxy, helping astronomers better understand its origin and evolutionary history. Although current models suggest that galaxies could not have grown to such vast sizes in the comparatively short time since their formation, the data challenges this assumption. Previously, galaxies were generally categorized into 2 groups: ellipticals, which are smooth, spherical masses of light, and spirals, which feature disk-like structures with spiral arms of gas and dust. Until now, astronomers believed that galaxies in the early universe wouldn't display the organized classification we see today. However, observations from the James Webb Space Telescope challenge these assumptions. revealing that many ancient galaxies are very bright and structured, similar to galaxies in the nearby universe. The surprising size and brightness of these ancient galaxies has led some astrophysicists to question the age of the universe. According to one researcher, the Earth is 26.7 billion years old, almost twice as old as before. However, this theory is still controversial and has not yet been established. Possible explanations for the discrepancy between observational data and current theories include the role of dark matter in the early universe and the unknown mechanisms involved in galaxy formation. Even before the development of the James Webb Space Telescope, scientists knew that the ancient world was very different from the world of today. During that era, galaxies were primarily composed of hydrogen and helium, shaped by dark matter and populated by enormous, short-lived stars. The chemical makeup of the early universe differed from the modern cosmos due to the absence of heavy elements. Older stars, known as population 3 stars, were much different from today's stars, being larger, hotter, and bluer, and emitting more ionizing radiation. While no direct observations of population 3 stars have been made, scientists believe that James Webb might be able to identify these elusive celestial objects, offering valuable new information about the early cosmos. The telescope is essentially meant to transform our knowledge of the early universe, providing a window into the distant history of the cosmos and illuminating the fundamental processes that shaped its evolution. Exciting data collected by James Webb brings us closer to discovering the world's first mysterious stars. While it may seem simplistic to talk about history billions of years ago, it is important to understand the world from our modern perspective. Thanks to its excellent capabilities, the James Webb Space Telescope will reveal the unseen world and provide unprecedented views. It is important to gain a deeper understanding of the origin and evolution of celestial bodies, such as our Milky Way. Because astronomy works on large scales, we cannot directly observe galaxies throughout their lifetimes. Like imaging the Milky Way, astronomers must study distant, ancient objects to analyze the evolution of galaxies. This research is essential to understanding the complex processes of formation and evolution of galaxies, and provides important new insights into our origins. The search for extraterrestrial life is also a fascinating avenue. NASA recently revealed that 17 exoplanets have been discovered that have subsurface oceans hidden beneath thick ice sheets. These worlds, like the cold moons of Jupiter, are expected to find biological signatures or chemical signatures of life. Subsurface oceans may be maintained by internal heating mechanisms, such as radioactive decay and tidal forces from their host stars. Even with cold surface temperatures and lower density than Earth, cryovolcanic eruptions, similar to ice volcanoes, could indicate geological activity and potential life habitats on these worlds. In a stunning discovery, researchers have unveiled the dynamics of Mars' atmosphere, revealing a brief event where part of the planet's atmosphere was swept into space. NASA's Mars Atmosphere and Volatile Evolution (MAVEN) orbiter witnessed this event, highlighting the dynamic interaction between Mars and the solar wind, offering new insights into how the Martian atmosphere responds to solar activity. These findings extend beyond scientific curiosity, influencing our understanding of planetary systems, habitability, and the larger forces shaping the universe. The new discoveries we make as we explore the world help unravel the world's mysteries, dispel myths, and expand our understanding of the world. The unusual phenomenon observed by the MAVEN satellite in studying the dynamics of the Martian atmosphere is remarkable. It appeared when a region of the solar wind was moving through the slow region and removing material from the Martian atmosphere on December 25, 2022. This scattered region gave scientists a rare opportunity to observing the state of the Martian atmosphere under orbital conditions. A problematic star MAVEN project manager Jasper Halkes called this unexpected event a Christmas gift from nature and provides a perfect science model. This allowed scientists to investigate how strong solar flares, or lack thereof, affected the Martian atmosphere and shed light on the planet's evolution. These findings will help improve models of planetary atmospheres outside the Milky Way, providing more methods for understanding Earth-like planets and their interactions with host stars. As the peak of solar activity approaches, astronomers predict that similar events will occur in the coming years. Monitoring and analysis of data from MAVEN and other missions is expected to shed more light on the complexities of Martian atmospheric dynamics and their significance for planetary evolution. In other news, NASA announced that problems with the Hubble Space Telescope have been resolved. After several errors in one of the gyroscopes, the telescope is working again. Despite its age, Hubble has been studying the universe for more than 30 years, an important tool for unraveling the mysteries of the universe, supporting the work of new observers and making progress in deep space exploration.